Hello students, we have studied the Pythagoras theorem in standard 7. According to this theorem, in a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Hence, in a right angled triangle, if we know any two sides, we can find the third side by using the Pythagoras theorem. Correct? Now, observe the diagram. In triangle ABC, angle B is equal to 90 degree, AB is equal to 3 cm, BC is equal to 4 cm. We can find the length of the hypotenuse AC by using the Pythagoras theorem. AC square is equal to AB square plus BC square. Therefore, AC square is equal to 3 square plus 4 square is equal to 9 plus 16 is equal to 25. Therefore, AC is equal to 5 cm. So, in a right angled triangle, if the lengths of the sides forming right angle is 3 cm and 4 cm, the length of the hypotenuse is always 5 cm. Here, 3, 4 and 5 form a triplet, which means we have a set of 3 numbers in which the square of the largest number is equal to the sum of the squares of the other 2 numbers. Understand? In a triplet of natural numbers, if the square of the largest number is equal to the sum of the squares of the remaining 2 numbers, the triplet is called Pythagorean triplet. 3, 4, 5 is a Pythagorean triplet. Numbers in Pythagorean triplet can be written in any order. For example, 4, 3, 5, 5, 3, 4, etc. 41 is the largest number in the triplet 41, 40, 9. 41 square is equal to 1681, 40 square is equal to 1600 and 9 square is equal to 81. 1600 plus 81 is equal to 1681 is equal to 41 square. Here, the square of the largest number is equal to the sum of the squares of the other 2 numbers. Therefore, 41, 40, 9 is a Pythagorean triplet. Verify that 5, 12, 13, 7, 24, 25, 11, 60, 61 are Pythagorean triplets. We have studied that 3, 4, 5 is a Pythagorean triplet. By taking equal multiples of all these numbers, we once again arrive at another Pythagorean triplet. Let's see the example. The triplet 6, 8, 10 obtained by doubling each of the numbers in 3, 4, 5 triplet is also a Pythagorean triplet. Let's see the justification. 10 square is equal to 100 and 6 square plus 8 square is equal to 36 plus 64 is equal to 100. Therefore, 10 square is equal to 6 square plus 8 square. Similarly, we can get the Pythagorean triplets 9, 12, 15, 12, 16, 20, 15, 20, 25 from the multiples of each integer of the triplet 3, 4, 5. In the same way, we can get an infinite number of the Pythagorean triplets from other Pythagorean triplets. You may verify this. We studied one method of finding a Pythagorean triplet. Now, we will study the formula for finding a Pythagorean triplet. Formula for Pythagorean triplet: if A, B, C are natural numbers and A is greater than B, then A square plus B square, A square minus B square, 2AB is a Pythagorean triplet. For example, if we take A is equal to 7 and B is equal to 5, A square is equal to 7 square is equal to 49 and B square is equal to 5 square is equal to 25. 7 is greater than 5. Therefore, A square is greater than B square. A square plus B square is equal to 49 plus 25 is equal to 74. a square minus b square is equal to 49 minus 25 is equal to 24. 2ab is equal to 2 into 7 into 5 is equal to 70. The largest number is 74. 74 square is equal to 5476. 24 square plus 70 square is equal to 576 plus 4900 is equal to 5476 is equal to 74 square. Hence, 24, 70, 74 is a Pythagorean triplet. In the same way, find the Pythagorean triplets of various natural numbers of your choice and verify them. Proof of Pythagoras Theorem. There are various methods to prove the Pythagoras Theorem. We have proved the Pythagoras Theorem by using the areas of 4 right-angled triangles and 1 square. Today, we are going to study the proof of Pythagoras Theorem by the similarity of right-angled triangles. Pythagoras Theorem. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining 2 sides. Let's see what's given. In triangle PQR, angle PQR is equal to 90 degree. To prove PR square is equal to PQ square plus QR square, construction. Now draw perpendicular segment QS on hypotenuse PR from point Q. Point S lies between point P and point R. Proof. In the right angled triangle PQR, segment QS is perpendicular to the hypotenuse PR, according to the construction. Triangle PQR is similar to triangle PSQ is similar to triangle QSR because similarity of right angled triangles. Triangle PQR is similar to triangle PSQ. Therefore, PQ upon PS is equal to QR upon SQ is equal to PR upon PQ because corresponding sides of similar triangles. Therefore, PQ upon PS is equal to PR upon PQ. Therefore, PQ square is equal to PS into PR. Equation 1. Similarly, triangle PQR is similar to triangle QSR. Therefore, PQ upon QS is equal to QR upon SR is equal to PR upon QR because corresponding sides of similar triangles. Therefore, QR upon SR is equal to PR upon QR. Therefore, QR square is equal to SR into PR. Equation 2. Adding equation 1 and equation 2, PQ square plus QR square is equal to PS into PR plus SR into PR. Therefore, PQ square plus QR square is equal to PR into PS plus SR is equal to PR into PR because point S lies between point P and point R. Therefore, PQ square plus QR square is equal to PR square. Therefore, PR square is equal to PQ square plus QR square. Understand? Now let's study an example. Observe the diagram below. In triangle ABC, angle ABC is equal to 90 degree. Segment BD is perpendicular to segment AC. Point D lies between point B and point C. Segment AD is equal to 9 cm. Segment DC is equal to 16 cm. Now, find lengths of segment BD, segment AB and segment BC. Let's see the solution. Given in triangle ABC, angle ABC is equal to 90 degree. Segment BD is perpendicular to segment AC. Point D lies between point B and point C. Segment AD is equal to 9 cm. Segment DC is equal to 16 cm. By theorem of geometric mean, BD square is equal to AD into DC. Therefore, BD square is equal to 9 into 16 is equal to 144. Therefore, BD is equal to square root of 144. Therefore, BD is equal to 12 centimeter. Equation 1. Triangle BDA is a right angle triangle because segment BD is perpendicular to segment AC. Therefore, by Pythagoras theorem, in triangle BDA, AB square is equal to AD square plus BD square. Therefore, AB square is equal to 9 square plus 12 square is equal to 81 plus 144 is equal to 225. Therefore, AB is equal to square root of 225 is equal to 15 centimeter. Equation 2. Triangle BDC is also a right angle triangle because segment BD is perpendicular to segment AC. Therefore, by Pythagoras theorem, in triangle BDC, BC square is equal to BD square plus DC square. Therefore, BC square is equal to 12 square plus 16 square is equal to 144 plus 256 is equal to 400. Therefore, BC is equal to square root of 400 is equal to 20 centimeter. Equation 3. What did we learn? In a triplet of natural numbers, if the square of the largest number is equal to the sum of the squares of the remaining two numbers, the triplet is called a Pythagorean triplet. If A, B, C are natural numbers and A is greater than B, then A square plus B square, A square minus B square, 2AB is a Pythagorean triplet. We learned this formula for the Pythagorean triplet. We studied the Pythagoras theorem. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides, and the proof of Pythagoras theorem by similarity of right angle triangles. Exercise. Identify with reason which of the following are Pythagorean triplets. 1. 9, 12, 15. 2. 15, 16, 17. 3. 10, 24, 26. 4. 32, 48, 24. In triangle PQR, QS is equal to 6 cm, RS is equal to 4 cm. Now, find lengths of segment QR, PS and PQ. In the figure given below, triangle ABC and triangle ECD are right angle triangles. AC is equal to EC is equal to 6 cm. AB is equal to 4.8 cm. ED is equal to 3.6 cm. Find segment BD.